welcome to the workshop. So thanks for coming to the session.
Hello guys, sorry for the slight delay. Yeah, so I am Chirag Kotian, third year BTech Electrical. I am head of Techmaniacs Club. So majority of you would have seen this presentation, so I would just go past it. So yeah, Techmaniacs is a robotics and electronics club of IIT Tirupati. We generally do projects, take part in competitions, and also we help students to learn new skills. Like we provide them components, we provide them resources if they want to learn something in the field of robotics and electronics. So yeah, as I said, what is our mission? Our mission is to induce a technical culture in our college and boost innovation. So this is the club structure of Techmaniacs. In Techmaniacs, there are 4 interest groups: electronics, Arduino and single computer boards, robotics, and drone interest group. So this is the introductory session and workshop for electronics interest group. This interest group is a new addition to our club. So as you can see in every interest group, there is one interest group head. For electronics club, it's Tarun Bhaiya. So under him, there are some co-coordinators who have certain tasks. You can contact them if you want components, you want to discuss any projects, or you want to take part in any project. You can contact the co-coordinators of the respective interest group. So as you can see, there are 4 interest groups, and there is a asterisk mark on the 3D printing. So earlier 3D printing was a separate interest group in our club, but we thought that 3D printing has become such an important skill that everyone should learn it, 3D printing and 3D CAD modeling. So it is required for every prototyping stage. So I would say that you should start learning it, because it's better if you can represent your ideas in a 3D form. So these are the interest group heads. You can also see the roles which they have. So yeah, I will be sharing everything. So how you can be a part of the club? So co-coordinators and me myself form the core team of the club. Then comes the members. So being a member is very easy in our club. You just have to take part in some competition or do some projects, or engage in club activities like this workshop. So if you are a member, you get an access to all the components which club has. So if you have some component in access and you want to do some projects, we will provide you that. We will also provide you some resources through which you can start learning. Also, we are building a documentation, we are building a GitHub repository where we document all our projects. So once it is properly done, like it's newly started, so there are few projects now, but slowly and gradually the size of that will increase. So if that documentation is supposed to be very extensive, so in future, if anyone wants to work on some pre-made project or start a new project and they want some resources, they can directly refer to the documentation. It will have all these steps involved in making the projects and everything. Yeah. So yeah, this was a small introduction to the club. So if you have anything to ask or any project you want to do, just you can contact me or the co-coordinators, as I said. You can shoot me a mail at this, or that's my WhatsApp number. You can WhatsApp me also. So I call upon Tarun Bhaiya to start the workshop. So he will begin with introduction to electronics interest group.
Okay, first we will differentiate between the electronics and remaining clubs. Okay, up to the previous year, we have the drones interest group and robotics and Arduino and IoT. So if we see what differs this electronic interest group from the remaining thing, so basically drones is nothing but uses of aerodynamics and electronics, you can simply say, and other stuff. And if you see robotics, okay, don't laugh at it. And And if you see robotics, it's basically mechanics and electronics, a combination, and other stuff also includes in it. And don't laugh. So I have seen this washing machine in our college, which is collecting a lot of money from us. So it is an application of electronics and Internet of Things, communicating the stuff using Internet and Wi-Fi. So we can see here one drone interest group, what they fundamentally do, and one robotics, one IoT and Arduino stuff. And some might think the Arduino is a different thing. No, it's basically this one converted to the PCB made by a company in a standard format. It looks different if you compare those two, but people get scared after seeing these circuits. So some company came in front and they made these standard boards to use. And now the question, like, do you know the difference between electrical and electronics? Scale. I mean, what do you mean by scale? Electrical scale or electronics scale?
Electrical is on a larger scale, right? Electronics.
Okay.
Pratham. The people who are answering would be given chance to make the Bluetooth speaker. It is like the most difficult among three of it. So if you want to do hands-on on that, I encourage you to answer more. Okay, we are writing names of people who are answering frequently. Okay, your name again? Pratham.
So, like, we have switchboard here, right? Do you think it is electrical or electronics? The switch, the current, the power supply that is coming to the switchboard is electrical and electronics. Electrical. So from the switchboard, whatever we do, that comes under electronics. Fine. So this is the Google that gave definition. So electronics, according to the definition, the branch of physics and technology concerned with the design of circuits, with transistors and microchips, blah, blah, blah. Okay. So let's see different type of electronics. So basically electronics is nothing but, as you know, you already cleared the J and this stuff, you know, the resistor, capacitor, inductor, this stuff, right? Transistor. Yeah. Fine. So for the electrical engineers, if you see our curriculum in our college for electrical engineers, these are the 3 subjects that they have to study to get a graduation. So power electronics, basically converting that 220 volt AC to the power that our phone requires, 5 volt DC. That's the hardware required for that. We can simply say mobile phone chargers that deals with this power electronics. And see, for example, if we have to use a calculator in our phone, a simple AND operation, like you give 2 inputs and we have to get one output, one AND operation. If you give 1 0, it should give 0, right? So that logical stuff comes under digital electronics, and the hardware that is doing comes under analog. You will know much about this when it comes to subjects. Okay? It's just for classification purpose. So let's go from what we know, what you guys know at this stage. Yeah, can you name some basic electronic components which you know, except what I said? Wire.
Diode.
Okay, diode. Yeah, rectifier. Diode is basically used as rectifier. Okay, these all stuff would be made using semiconductors. Fine. Sensors. Breadboard, yeah, breadboard. It's used for connecting the stuff. Motherboard. It comes under some other stuff, computer architecture, and fine. We'll discuss it later. Are you aware of this classification of active and passive components? Yes or no? So can anyone differentiate the fundamental difference between these two? Okay. Active generates energy, passive consumes energy. Okay.
Any more answers? From second year at least?
Is there any, like, why do we need compounds that generate energy instead of battery? Like we have batteries, right?
so that they can store it at like our capacitor, they can store it for some time and then
Yeah, capacitor can do that stuff. Okay. How are you thinking that an electrical component can generate energy? Like, where does the fundamental power coming from that? From chemicals. That's what battery is made of.
like the battery will give energy, battery energy will give the heat energy.
Name.
Changing magnetic field,
Changing magnetic field, that I guess it's inductor.
light,
Light.
photovoltaic.
Yeah, photovoltaic cell. It is solar, right? Basically, it takes light and gives energy.
Name your name.
Okay, fine. The main differentiation between these active and passive is, as you are already aware of metals, non-metal semiconductors. So semiconductor are a type of materials where we could control their conductivity from by doping some other components. Like as you know, silicon, right? We dope some p-type and n-type to make them respective thing. So through that doping, those active components gain a small amount of energy. So that I mean, you might get doubt like why the need? Why do we need only to store small? I mean, why do we need only to give some capability to that active component to generate power? So that plays a major role in the computation and part. Like we have our processes, right? So though these active components play much role. Okay, how many of you have seen this meme? Okay, fine. I'm also seeing this first time while making the PPTs. So, what do you know about transistor? So, when someone calls you and asks what is the transistor, what do you say? Like for a 10th class kid,
Non-mechanical switch.
non-mechanical switch. Yeah. Yeah, that's why as it could be used as a non-mechanical switch, the computer we are using today is came up. Before that, we have a mechanical computer, the first one which I think Charles Babbage made. Any more?
A transistor is a device that can modify the value of current and voltage.
So you are saying it can modify value of current and voltage. So normal conductor can do that.
Like we can control the values on
Yeah, controlling current. Okay. So basically, we can control the amount of current that has to flow in a transistor by another input signal or another current value, which we can refer it as input.
like we can give another input and based on that input it can give output.
Yeah. So the reason why we are using the transistor till today is, I mean, so many reasons, but why it is using in computer, we can simply say, as those two mentioned, it could be used as a electronic switch. And how it is, he mentioned like using the current signals, we can control another current flow. And do you know about Nobel Prize? Like to whom it would be given? Actually, Nobel Prize would only be given to the people who work in the field of science, not in engineering. Basically, engineering is application of science. We study the stuff which we made, which are already made and could be made. But this transistor is the only one which got Nobel Prize. Like the one who made this transistor was awarded the Nobel Prize because it's a turning point in the era of computation and then era of electronic things.
So, you know, there are three states in transistor, three working states. So you must be familiar with those three states. Can anyone like to add on, like, what are the three states?
One is amplifier,
Huh?
a switch on and switch off.
Okay, but like saturation state, you know, like that there is two more. So who gave that answer of amplifier? Okay. Your name? Om. Okay. Acha. Any two more states we have? Like apart from saturation, what are the two more states? Answer. Okay. So cutoff state and active state. Okay.
Cut off active saturation.
So active components have ability to manipulate the current. Like someone has, like someone know voltage dependent current source and these sources. So in circuits, if you want to like manipulate the current and the signals, so active components are used for those things. These all the transistor and like switch. If we have a transistor in between and we are giving we are giving some minute current to the base value, so it can turn the switch on or off. So that is the power of transistor. Like other passive things cannot do it, depending on the external signals. One add-on.
So I'll simply draw some difference between a conductor and a transistor. Like as you people said, we can apply some plus 5 volts here, 0 volts here, and I can apply some X volts here. The current would be flowing this way, like electrons flow would be this direction, right? So in case of conductors, if you want to control the flow of this electron without changing the voltage between these two terminals, you could use some other wire and give some, let's consider 100 volts. So does the current in this wire changes? Are you sure? Let's say this resistance is 1 ohm. So we'll get 5 amperes of current. Yeah, finish. So what my professor said in my class is, if we calculate the exact number of terms, the amount of current that might change is 4.9 or 4.8 amperes. Current would still flow. So as there are a lot of charges here, it is not possible to control this flow using an external voltage in a conductor. So there are in a conductor, you would know there are a lot of electrons, right? So if you look at the transistor, you know NPN, PNP. So what are the major charge carriers in the P? Minor? Okay. So I'll take the minor charges here and try to control it. Because I could only control only minor charges, I mean less number of electrons or holes using the external signal. So if I give some voltage here, these minor charge electrons would form a channel, and based on the input voltage, this channel would increase so that my conductivity increases. So can you understand something from it? Why we use these transistor and why can't a conductor? We try to use the concept of minor charge carriers, not major, because we could only control the minor charge using some external voltage. explain first. Have you heard about OPAM, Operation Amplifier? OPAM, it is also an active component which is made up of transistors.
So there's an internal circuit in the op-amp that you can see on the right bottom part. Okay. So basically op-amp is like, it is a widely used IC chip that we like use almost in every circuit. So what we do now, instead of always checking this, this op-amp, we can make it from like using different transistors and wires. But we always use IC to shorten our like working stage. So basically, we want to explain the whole concept of op-amp using simulation. The op-amp itself is called like operation amplifier. So what do you think? What it can do from its name? Answer. See, it's like amplifier. I know it can do, but operation. What are the operations? Basically, you know.
What are the arithmetic operations, you know?
Arithmetic operations. Okay, so addition, subtraction. If you want to do with help of circuits or normal circuits, so like addition, subtraction is okay, but we can use, like we can differentiate the signals as well, differentiate and integrate using op-amps. So we have different types of circuits of op-amps that we are going to simulate now through a software, like through a software called Folstad. Okay, so Ganesh Bhaiya, you continue with the Folstad software.
Okay, just before I go with the simulation parts, as you can see here. So so this is the IC part. So what op-amp looks in reality, and then also the arrangements of the op-amp and this. So I'll just show the simulations of the op-amp.
Just a website open. Website open. Open the website.
So you can see the name here. It's Falstart. So this is one of the real time. Like you can find even.
It's just a software, not a software. It's just a web where you can go and simulate in online instead of downloading anything.
So it's like a simulator. You can say. So.
So as you can see there, there are two terminals for that triangle shape, something whatever you don't know. One is a minus and plus. So the terminal which has minus is called non-inverting, and which has plus is called inverting.
So you can just refer the simulation name here. నేను just change చేశాను వాల్యూ చేంజ్ చేశాను
సో ఎలా అవుతుందని
Okay, everyone, so as you can see here, so as you can see, I'll just show the simulation part. So you can see see that there are two different voltages. One is a sinusoidal wave here, and the other one you can see a square wave. So you can see the current of flowing from both the branches, and they're getting added up here, and at the end you're getting an output. So you can see the two different types of voltages here. So one is the sinusoidal and one is the square wave. At the end, you can see that we're getting a sum of both. So we can see a sum of both the voltages. So we can say that this is a summing amplifier, or you can say as an adding amplifier, which operates as an adding. So one arithmetic operation, that is addition of the voltages.
So you might get the doubt like what are those two terminals? You can see there. One is plus and minus, right? Those two terminals are referred as inverting and non-inverting. So there is a rule in op-amp, like we can blindly follow. The voltage of the plus and minus would always try to be same. So as the voltage of the plus terminal is ground, the minus terminal will also become ground. So we can see that wire in there, right? So the amount of current that is pumped to the minus terminal would directly go to the output in the sense. So using the current equations, you can find what is the output. Vout divided by 1 kilo ohm, Vout minus 0 divided by 1 kilo ohm equals to the amount of current that is pumped into that.
So it's just like operation. So the operation here, then there is addition or summing and also it's amplifying. It's not just directly adding, but it's also amplifying the output. So other two circuits I'll be showing. Guys, I want everyone. So this one, I'll just. Okay, a little while.
Ask them what is it doing.
Yeah, sure.
Okay, so this one is the input graph, this one is the output. So can you guess what is it doing? Fourier?
It is a simple function.
Like the functions I told you. For slope, then it's related to slope. Then
You're near class. Yes.
differentiate. You're okay, then.
I just want to it's
Right.
exactly as you can see here is a differentiating amplifier or a differentiator. So not only to this triangular wave, what we can see here is also applicable for other types of waveforms like AC. Yeah, sure. Yeah, so almost you can see here there's a sine wave here, and almost at the output we are getting a cos wave. I mean, it might look similar, but if you look carefully, you'll get a cos wave here, a sine wave here. And one last signal is okay. By the movement of the input and the output, what you guys can expect? Like, what is this doing? Okay, what's that? Yes, so integrating as you can say. So coming to the explanation of this simulator. So as you can see here, faster you can see the real-time simulation, like what exactly is going on in the circuit, and you can see the way current is flowing, and you can also see the voltage at the input and output. So you can also not only this, but you can also explore various types of circuits by you guys can look the cursor up here. So you'll find like circuits and start from basics. There's the Ohm's law and also other AC circuits. You can explore through various.
Yeah, if you just click on a particular thing, just click on one thing.
So I'll just our basic only this.
Yeah, the circuit, how it works, the current flow diagram you can see, the visualization of current flowing. So you can explore later this website. It's quite useful.
one of the most complex circuits. So all types of circuits we can explore through this simulator, real-time simulators. I see. No, you take now. Anyways, I have to explain this thing. Okay. Isn't my phone?
ये वाला
So can someone answer what is a IC? They can see and tell, then also it would be a big thing.
So what do you understand by the term integrated circuit? What is the difference between that term and that circuit which you are seeing there? Okay, if I put some capacitors and resistors and transistors and make a circuit on a breadboard, can I consider it as an integrated circuit? Okay, I'll put a full components of a full of this table and I'll integrate that. Can I consider that one as integrated one? Okay, I'll bring the small circuits and integrate them.
Okay, so the main purpose of IC is like what happens, we have commonly used circuits like a 555 timer IC. It's a very commonly used IC. So what happens, there's a circuit that we make, we use it in many other big electrical circuits. So what we want it to make it smaller and lighter in weight, that consumes very less power. For that thing we use a single semiconductor chip we use, and over that we make some carvings and we make a, okay, I would show you the picture. Okay, this one. So let's see, this is a very famous temple, and what happened there is, it was a single mountain, or we can like assume it's a single rock. So what happened, the architects carved it from above to bottom. So in the similar fashion, what happens, we have a single semiconductor chip, and that semiconductor chip we like read these two lines: etching the wafer to remove unwanted material and create the circuit pattern. So first we remove whatever the excess semiconductor we have, then we make same print that we want on our circuit, and then add impurities and dope it to we have semiconductor, we dope it to make p-type and type diodes. So it makes the circuit becomes very compact and simple and less power to use.
Did you understand the difference between IC and normal circuit which you make? So once to show the slide.
Which one?
So did anyone, next one, temple. So do you know this temple? Like, did anyone see in Insta Reels or somewhere in Google? Like, it's completely, instead of taking the bricks and other stuff and building it like a home, what they did is, they selected a certain mountain and they carved it literally. See those, each and every sculpture is from the same rock of a mountain. So what I'm saying is, instead of bringing the components and making them work on a breadboard, is like constructing a building with the bricks with certain components. So, but in case of IC, everything is made on that single wafer of semiconductor only.
Okay.
So it is a amplifier, quad bridge amplifier IC, which is used to amplify audio signals. So we'll look what are the fundamental things that would be there in an IC, a few popular ICs. So we'll then go on how to use them in practical.
So in this Bluetooth speaker, we are using this IC. What it can do, it can take inputs and power and amplify the signal and give it to 4 different speakers. That's why it's called quad bridge amplifier IC. Okay, so in this compact circuit diagram, can you name few of the components that you can recognize? Capacitors, okay. Op-amps and switches. Okay. So that on the top is the like actual IC how it looks like. We would distribute it later. Okay, so this circuit you can see the capacitor at the very left end. So what it does now, like the signal we are giving, it is a combination of DC and AC signal. So this capacitor is called a coupling capacitor that we use. And like I want to add on one point. This whatever you see this block diagram, it's not the actual structure inside it. The companies usually used to hide sometimes. They don't reveal the everything in this IC so that people won't copy it out. Okay, so the few things I can add on in it. It separates out the DC and AC output so that speaker can work accordingly. It amplifies the signal. It provides and distributes the power between 4 different speakers. And okay, and it's like it also sends feedback signal that second year know, but you don't know.
Okay, fine. One show me that. So, as I said, this is basically an audio amplifier, an IC of an amplifier which contains some operational amplifiers to amplify our audio signal. So, what are you thinking? Is our like let's take a song. Is it an AC signal or a DC signal? AC or DC? Okay. So let's take some X song, some famous song, and I'll add some 10 volts to that signal. Signal is in the sense, as you said, it would be AC and it would be in the form of voltages. So let's think I have added a 5 volt or 10 volt to that. So if I directly give that one, that 10 volts also will try to get amplified, right? So that part is not needed for me. So what I do is I'll just put a capacitor there. There is a basic quality of capacitor which is that it won't allow the voltage to change rapidly. Right? The DC component would just suck on the capacitor and the remaining AC, that song signal which we want would go enter into the amplifier and give us the output at the speaker.
Okay. So now we continue on our first project, that is a Bluetooth speaker. So can someone guess what are the components we are using in it? Can someone divide what are the all things we require in it? Transmitter. Okay, so its name is Bluetooth speaker. So what should be the transmitter? That's a usual answer. You can write name. Okay, and what are the other things? Driver. Can you elaborate what do you mean by driver? Speaker coil. Okay, you mean the speaker at the end. Okay, and
The speaker, the Bluetooth module and
power source.
yeah,
Okay.
we have sockets there, we'll use them.
It's okay if they are answering. Huh? Transformer, okay. And IC I discussed before it. Can someone remember its name? Okay, yeah, quad bridge. Okay. किसी का name लिखना. Okay.
So the thing is, as you know, the song would be in a small voltages in the form of digital bits, which is less than 5 volts. It has to send to the amplifier, and the amplifier would send that stuff to the speaker. Then it will give our output.
Okay, so most of the things you guys told correctly. There's one more thing that we use, that's a regulator. So what happens to give a steady supply to most of the components that is voltage sensitive, we use a regulator. Here we are using a LM regulator that I would tell you later. And this thing you may be familiar with. Can someone tell what is a heat sink? You can answer again.
Extracts heat from like processing units.
So why do we require a heat sink?
Like extreme heat can damage the component.
Yeah. Okay. Bhaiya, his name. Your name? Om. Okay, it's already done. Okay. So, okay, one guess. What is SMPS? Okay, correct answer. You? Huh. Okay, so Bluetooth module, most of the things are written, you can read. Okay, so main task is to like we can use it in many other things. Like we are using here in it this speaker, but we can use for calling. Like we want to make next time a earphone, let's say, for cutting or managing calls. We can use this. Okay, so the terminals you can see you may learn few of those because the people who are making the Bluetooth speakers should know what are the terminals we are using next. So what is L, G and R? Okay, it's written again. Audio amplifier. Okay. So I discussed already what it is. It is this IC TDA what I told you before, the block diagram I gave it to you. It has like 16 terminals or more, I don't know. Okay. This is the voltage regulator that I told you. It gives a constant power supply. So there's a fault in it. What it does now, it takes a high voltage and provides a steady voltage that we require. But all the excess voltage and the power we have, it dissipates it in the form of heat. So that is one issue that it is giving, but still it's very useful for our circuit. Bluetooth.
So can you see the circuit and name what components could be, like if you have any idea on the Bluetooth module? What is that black thing? Yeah, just remember, wherever you see a black thing on a circuit board, it's IC. And we can see that metal thing there. It could be an oscillator, like to generate a pulse, like to generate a clock signal. And there you can see the Bluetooth antenna. So basically it has to send the data wirelessly, right? It need an antenna.
Okay, so this is the power supply we are going to use next. The inter circuit, if you are interested, you can check it out later. We won't discuss it here. नहीं, it would become later. 3 प्रोजेक्टर लेट हो जाएगा. लेट हो जाएगा.
Here, if you see like a switch mode power supply, what it does is basically there would be a DC voltage. So we use a switch so that we only take that DC voltage at a certain amount of time. Like if the voltage is like this, 10 volts, I use a switch.
Can you change the chart?
Let's say this one has 10 volts. This is my input. So when I switch it, my voltage would be like this. So from DC to it got converted to, we can say AC. And if I integrate it, like let's say this time period has 1 second. So for 0.5 second, my voltage is high. 0.5 second, my voltage is low. I'll integrate it. So I'll get a 5 volts constant voltage if I integrate this using a capacitor and stuff. So that's what it meant. Switching, switch mode power supply. So we use the concept of switch here, and there will be some feedback things also to maintain our output voltage constant in certain range.
Heat sink to dissipate heat. That's all it do.
Does anyone know how a speaker works?
Okay. So like the things we are using in a speaker, we just want to show you a small video so that you can get a idea how does a speaker works. Okay. छोटा ही है चलो.
So there the audio signal is passing through from mic to the air to the speakers. as someone mentioned before, driver. Let's see what's inside a driver. So you're all aware of the lens law, right? So can anyone tell me what is lens law? Okay, change in magnetic field. So can you tell same definition in reverse point of view? I can say change in current or change in voltage can induce a magnetic field, right? Is it lens law or Faraday's law?
Like it opposes the
Okay,
current.
fine. So what I meant is here the signal which is in the form of current, like the audio signal which is in the form of current, will pass through that coil and it got converted into magnetic signal. Current signal to magnetic signal. So if there is a fixed magnet there, if it is inducing some signal like 1 and 0, let's consider high voltage, low voltage, high voltage, low voltage, or high current, low current. So that electric signal is converting into magnetic signal, and as there is a magnetic field, so we have a fixed magnet in there that will repel that according to the signal. So it got converted in the form of vibrations.
Okay, so this is the circuit diagram we are going to use. Like I'm thinking to demonstrate all the projects together at the end. Shall we demonstrate it right now? Okay, at the end we would do it together. So like the people who have answered till now, we have few names, but you have still chance to add in this particular project. Okay, so I guess almost all the components you know in it now. There's no need for further elaboration. This circuit diagram we would provide you again for making it. So it requires soldering, so take care of your hands while doing soldering if we give it to you. Okay. So now, okay, can someone answer what we are going to make from it? I know, but yeah, how? But the components we're gonna use. Okay, buzzer is a correct answer, and frequency. Okay. Okay, I named one commonly used IC before. Can quad bridge and one more 555 timer I said. Okay, so this electric piano is actually using 555 timer. We would further give you a simulation of it, how it's working, and a brief description of 555 timer. Okay.
Below. I'll be using this column as positive rail and this column as negative rail. Place 555 timer IC on the breadboard.
So I guess in first year, are you familiar with the working of breadboards? You are, and others? No. Okay. So this at the end, it's a red line and blue line. You can see these red lines at the end. We have breadboard in it. The red line and blue lines. All the sorts are sorted together. All the ports are sorted together. Okay, let's whoever got this piano key, we would explain it to you at that time.
Place 555 timer IC on the breadboard with its notch facing up, and these are the pin numbers. Connect pin 8 to positive rail and pin 1 to negative rail. Next, connect pins 2 and 6 of the IC to each other, and similarly connect pins 4 and 8 to each other. Now place a 1 kilo ohm resistor between pins 7 and 8 of the 555 timer IC. Next, place a 100 nanofarad capacitor between pin 2 and negative rail. Now place a momentary push button switch on the breadboard. I have placed it such that the pair of interconnected pins are in this direction, and both the pairs will be connected to each other only after the push button is pressed. And you can find out which pair of pins are interconnected by looking at this symbol. Next, place a 4.7 kilo ohm resistor between pin 7 of the 555 timer IC and one of the pins of momentary push button switch. Now connect the other pin of the push button switch to pin 6 of the IC. Next, place another momentary push button switch on the breadboard with its orientation.
So it is the circuit at the end we gonna make. Like I guess you can directly replicate it. There's no more need to explain how to join these things. There's a further explanation.
Principle of this circuit is that we can hear sound because the speaker diaphragm vibrates. And we are able to produce different tones by changing the number of vibrations of the speaker's diaphragm per second. For example, for lower frequencies, the number of to and fro motions of the speaker's diaphragm per second are less than that of the to and fro motions for higher frequencies. And these vibrations are generated by turning the output on and off continuously for as many times per second as required. In the LED blinker circuit we made in one of the previous tutorials, we adjusted frequency of the output by changing the values of resistance using a potentiometer. And this is a short animation for the same. You can refer to that tutorial for more information on how fast this capacity reduces quickly for blinking LED circuit. And in order to get different tones, instead of using a potentiometer for changing the resistance, which is responsible for changing the frequency, we directly made an arrangement of different resistor combinations. And as discussed previously, pressing different push buttons will provide different resistance values between pin 6 and pin 7. And the resistance between pin 6 and pin 7 increases as we press push buttons away from the first resistor. As a result, we get different tones for different resistor combinations. And this is the formula for frequency of the output for any given values of resistance and capacitance. In our circuit, the value of R1 is 1 kilo ohms and the value of C1 is 100 nanofarad.
Okay, so now for the 555 timer IC, in the same software we have shown before, we again Shruti is going to explain how is 555 timer is working. Shruti.
Is my voice audible or should I use the mic? Small mistake. Just check.
ये कम एक्सप्लेन करना ये टर्मिनल्स वगैरह मन पता नहीं जाता ये कर यूज करना है ना
So, okay. I'll just show the circuit. You show the circuit. So, am I audible now? Okay. So, basically what you're seeing is the internal circuit of the 555 timer. You saw in that video that we are changing the frequency of diaphragm by doing on off with different And if by changing the frequency with which you are doing, switching it on, off, we are changing the frequency of diaphragm, that is producing different sound frequencies. So for that, to control the frequency with which the circuit is being on, off, we use this timer. Inside this timer, you can see those two rectangles. Those are nothing but comparators. They are operational amplifiers itself, which So here you can see the comparator. What is there in operation amplifier? You can see plus and minus and one here. Right? So we connect. We'll get two voltage. One to plus, V plus, and one to minus, V minus. If V plus is greater than V minus, V out will be positive. If V minus is greater than V plus, then the output will be V minus. So that is basically. Okay. What happens now? We can use this and then
लिंक हो रहा है देख नीचे लिंक हो रहा है वो देख बैटरी खत्म कर इसका पावर चल नहीं रहा है उसी पे WhatsApp
what happens with flip-flop is basically what is required over here is if you can read two inputs and then there is an out. So if S is 0 and R is 1, output will be 0. And if S is 1, R is 0, output will be 1. You just need to know this much. Okay. So what happens when we to make this circuit work? We have to generate waveform. Next. This timer can be used in three modes: A-stable, monostable, and bistable. In A-stable mode, it is like you'll get continuous square waveform. In monostable, you can think as if when you click the push button, it will change. And then you release it, it will still be high or low depending whether it is on high or low. And in bistable, if you click the push button, then it will change from high to low. And again you click it, then it will change from low to high. Like that. So the thing which we'll use here is A-stable mode. For that, we have to connect. Is the word visible completely? Now? So there are 8 pins in this chip. Pin number 8 is connected to DC and frame is connected to 4, which is DC. Then 1 is connected to ground. And 6 are connected to them.
ओरिजिनल वेव प्ले एक
What
बनाया
we do is we connect
इसमें दूसरा बनाया जो इसमें यूज हो रहा है
7
ये
is
बहुत करूँ मैं किस ब्रो मैंने तो कैसे करनी है
between 7 and 6 to connect another.
आपने उसको रोना नहीं एक मिनट अब तो फोन कुछ है इसको
So by adding the resistance, we can change the frequency and tell you the formula later. And then we connect this 2 or 6 to a capacitor, which basically charge and discharge because of which we get that frequency thing. So inside what happens? Now I have connected to positive thing and here you can see 3 registers, 5 kilo, 5 kilo, 5 kilo, 5. That's how it gets the rate. And do you guys know about voltage divider circuit? Have you used it in GE or over here in the office sector, electrical engineering sector? What it does is, it divides the voltage. So this is your V. And you are connected to ground. So what is the voltage over here? It will be V plus R1, R2. Voltage over here will be V into R2 by R1 plus R2. Agree? All of you. So similarly, now what is this? Whatever voltage is given at 8, it will divide it into 2 third parts. So 2 third V will appear here and 1 third V will appear here. Okay. So now look at this comparison. Negative is connected to 2 third of the voltage terminal and positive is connected to this part. When the capacitor is charging, you know the equation, right? V is equal to some V naught 1 minus E and all that. When this charging, the voltage at this point is very less. So positive is less than negative, so the output will be negative. So R will be 0. Okay. So if it is positive, if the output is 1, it will give you 1. Else it will give you 0. R is not is 0. Now look at this comparison. This is connected to 6 in the same point. So this is negative, it is low, and it will be B by C, that will be high. So again this will be 1. So 1, 0. So the scope will be, according to that truth table, S is 1, R is 0, output will be 1. So then this goes to output divider, which basically inverts. So if it is 1, output will be 0. If it is 0, output will be 1. So in this case, so this was, so accordingly you will get that 0 thing when the capacitor is charging and discharging. And then what happens once the capacitor is charged? This will become, when the capacitor is charged, this will again, this will be higher than positive thing. It will be 0 here, and then V plus will be higher than 2 by 3 volt. It will be 1, 0. So it will be 0. The clock output will be 0. You will get, this is higher. So when once the capacitor is charged, this point will be at higher potential. So V plus is at higher, this is at lower. So what you will get is 1, and this will be 0. So 0, 1, your output will be 0. You will get the negative because it will be center. As I told you, it will be inverted. So then the transistor will start working, and the whole current, whatever it is there, will start flowing from this 7 to ground. So again it will start discharging. Are you able to understand, or is it confusing?
Samlesh दिखाएंगे समझो. Is it
AND gates or NOT gates? You might have seen in your JEE, right? So have you heard the term flip-flop? So basically a flip-flop is like you can say memory for your circuits. You have memory card for
सही है वो सही memory element है. It's more
consider flip-flop as a element
But how
and
does that
element
extend
which can
it?
store either a logic 1 or logic 0.
मिल गया.
So basically it's connecting to, you can realize it connecting to NOT gates or to NAND gates.
ये
Let's later after the workshop you can go and see how like connecting input of one NOT gate to output of one NOT gate, making the logic to be in a loop, so that we realize that it has a stored element.
कंटिन्यू करते हैं.
So basically what happens is the charger, it will give you some higher voltage, and when it is charging, it will give you low voltage, and the capacitor will keep charging for the next circuit, and that's how you will get high, low, and then the range with which it will charge and discharge will depend on these two resistors. So in that experiment, what we are doing, we are varying the second resistor by clicking different push buttons. You can see in this diagram when you do the process, and that's how we change the frequency and sound. We change. So that's how basically this thing works. We have a simulation over here. Now it is charging, and then this is discharging. So this is all you learn next year in your digital systems course. So don't take.
इसको बताएगा नहीं, वो ज्यादा हो जाएगा. Okay, it's again the internal of the 555 timer IC.
On the board, it's that you can see it on the simulation here, and you can see the functioning.
These two are comparators, and that NAND gate, NOR gate, that stuff is. So two are NOR gates, and that is flip-flop.
See there you can see two NAND gates where one output of the NAND gate is connected as input of another. Okay, and two gates where one output is connected as another one input, and the second one output is connected as first one input. There we are making the logic in a loop, like we are wrapping the logic in a loop, and that's how we are realizing a memory out of these circuits which you like combination circuits.
What's the gist of it?
लगे तुम लोग करो. ठीक है.
So So I guess this was a complicated part that first year don't get. So don't worry. After that, we have a simple task. It is a Li-Fi project. So the receiver and transmitter circuits are so simple, but we think transmitting data and the audio signals from the light, it seems difficult or easy to you. What's your opinion? Transfer audio signals through light. Any opinions? Easy or difficult?
We do have Wi-Fi, right? Like we can't see the radio signals which are going. The question is, can we communicate through the light which we can see, visible like RBG?
Yes. Okay. So what are the things we can use for that communication? Okay. So definitely we need a LED or a laser to transmit data. And to receive it, what shall we use? Huh? Who is answering? Photodiode. So, okay, so have you heard of photosensitive resistors? Okay. And what are the things is very common we all use? Like it's very common. Photosensitive. Solar panels. Solar cell or solar panel. Okay, so we are using here solar panels to receive the data, and to transmit we are using a simple LED. Okay. Okay, so Li-Fi fidelity. Okay. Okay, so can someone tell if we start using Li-Fi technology from now, do we still need Wi-Fi technology? Yes, answer. Why? Direct line of sight. Okay, so there's one disadvantage of it. It doesn't need direct line of sight. It means from if I'm using my transmitting my data from this room, a hacker have scope to like get that data somehow from the other room as well. So here Li-Fi what it applies na, like it needs direct contact with the light, direct line of sight of the light. So it's more secure. Okay, what are the other advantages that you can tell about Li-Fi? Better range. Okay, range is still a issue for us for Li-Fi. Like in optic fibers, we have a very good range, but we have a medium then. It's not, we are not transmitting light open in the air. Okay, so range is not an answer for that. Better efficiency and okay, good. His name is written. Your name? Netik. More answers. Advantages of Li-Fi. Okay, very common answer is higher speed. Yeah, I was expecting that. And okay, so you know about the telecommunication companies, they usually auction the bandwidth of radio waves. Everyone knows about this. Okay, so like people have to buy it, but if we start using Li-Fi and transmit big data from light itself, so the workload over that radio frequency can be eliminated. Okay, so there's one more point I would add later. Okay, so sometimes like what happens, Wi-Fi actually uses radio signals, radio waves. So in in hospitals and there are some nuclear fusion labs as well, where their radio waves can interfere with the appliances. So we don't, we need an environment where there is no radio waves. So there also Li-Fi is a great help. So this is a aux cable. You just see the circuit diagram. Okay, we are going to use it in our project.
And I did the diagram before, like what are the specific use of those rings on audio.
So so left, right, what does it mean? Stereo. Huh? Okay. So have you heard, like have you ever heard 8D audio song? Huh? If you search on YouTube songs, like we have 8. You would feel that, huh? I don't get you. you would feel like sound is coming from left and then right, left and then right. Okay, so that principle is it's shown this wire through this wire. Okay, so the working of this Li-Fi. So what happens? We are transferring the audio signal in the form of bits 1 and 0. So we connect this wire and the LED and a battery in series, so that when we are giving a bit high, our circuit would become complete, and when we are getting a bit lower bit, that is 0 bit, our circuit breaks. So what happens? Our LED light would flicker. So can you detect this flickering? Huh? Okay, so if I transfer a audio signal right now in front of you, so can you actually see the light flickering or not? No. Answer from this side. You are very inactive. What do you think? If I if I try to transmit data through light, would it flicker or not? I am asking from you guys. Tell. It would flicker, right? Would it be visible? Okay, so the frequency we have seen before in square wave pulse, it was very high, and the flickering would be very high, very fast. We cannot detect it by our naked eyes. So this is the transmitter circuit we are going to use. Circuit is simple. There's no further need of explanation for this.
Stereo signal, right stereo audio signal. So we connected those two signals to two different LEDs, so that signal in the form of current is converted into the light signal. So it will transmit the data on the receiver end.
Okay, some basic questions again. What do you think if I use two LEDs side by side for for left and right stereo? Okay, so should I do this thing or not? Like there's a LED in my left hand and right hand. They're transferring data for the left speaker and the right speaker. Should I keep those close or not? No. Why? What is the answer? Why no? Interfere each other. Okay, so if we are transmitting, there should be a separation between those. Okay, and one more question. Let's one of you answered about the stereo mode. There's one called mono audio. Can someone tell what is mono audio from the back? I want this answer. Okay, so left and right signal would be given to the same LED. Okay, so it would be your objective while making Li-Fi project. I would ask you to convert into a mono audio. It would be very simple, and I would give you a different amplifier for the receiver circuit. Okay, so this is a PCB we are using in our Bluetooth speaker. It has access to stereo mode. It can avail you with what I say, left and right speaker. Okay, but there's one more PCB. Okay, there's a class D amplifier that I want to show you. You removed it. Huh? Okay. Okay, everyone knows it. Specs, no. Hell no.
Previously, you showed the transmitter circuit, right? Using the LEDs, there we can see. Now, what do you think the stuff would be there in the receiver side?
Photoresistor, okay. What else? Battery we don't require actually. We require. Okay. I would answer you why I changed the answer. Okay, so the amplifier, it has I speak. Okay, so these are the solar panels. Okay. Okay, so these connections are very simple. If you see, all we need is solar panel and this amplifier circuit. Okay, so instead of this is our handmade amplifier. I do have one more amplifier, that's class D amplifier. So the amplifiers are divided into parts like class A, class B, class AB, and few more. So the major difference is in between efficiency. This one has very low efficiency of 50 to 60%, but the one I would give you has 90% efficiency. Okay. If you have any questions, you may ask. Okay, thank you. So let's skip to the hands-on project. We already have very less time for those. We would try to manage out in the limited time. Okay. So for soldering purposes, this front bench I would allot for soldering. Okay. Subdeep Bhaiya would be guiding you for like any further experiments. Okay. So Bhaiya, announcements of the name, please.
So on the screen we can see the upcoming projects. So it's also for you all. So you can also join us and you can also join us in making these projects. So along with the team. So anyone interested, they can come forward and they can take care of this project. So the first project what we have is a FM radio station for our institute. So apparently we are planning to have a FM transmitter and a receiver. So which we discussed previously in the slides, so that we can have like a small communication center. And also we can see here a micro mouse range using electronics, like somewhat a bit like robotics also. So these are the upcoming projects and more. So if you have any other suggestions, anyone is open to, you can express, you can give us the ideas in the group. And also if anyone is interested, you can just inform your friends and they can also join us. Thank you.